Why factor a quadratic function? Let's take a look. So the factored form of a quadratic function offers a solution because of the zero product property. If you have a statement that says a times b equals 0, then three things are true. A is 0, b is 0, or both of them are 0. So one of those three things is true, and we're going to use that to our advantage. So here's a factored form of a quadratic function. So what this tells us is that one or both of those is true. And so what we assume is that we can make one of them true to be 0, and we can make the other equal 0 as well. So we'll start with the first one, x minus 4. Let's assume that one equals 0. Well, if I solve, we're going to add 4 to both sides here. So the x value that makes that 0 is 4. If I assume the other part is 0, subtract 5 from both sides, divide by 2, I find out that x is negative 5 halves. So the value x equals 4, or the value x equals negative 5 halves, will make this statement be 0. So these are my two solutions of my quadratic function, because they each make the quadratic function equal to 0. At any point, feel free to pause this if you're taking notes or you want to take extra time to digest something, or work ahead and see if you have the right idea. So we're going to look at solution types here, and there are three different solution types when we look at a quadratic function. There's two solutions, and the function is factorable. So we see the function there, f1 of x, and we see the two solutions, negative 5, 0, and 1, 0. If we look at the factored form, we can see that there are a couple things that we can automatically tell how it's related. So first of all, the value negative 5, if we were to let this part be 0, what we just talked about for the zero product property, negative 5 fills that role and makes this part 0. So we know that negative 5 is a solution. The factor is x plus 5, because we know negative 5 is the value of x that makes the function 0. Same thing over here, positive 1, substituted into our second part, will make that part be 0. So we can say that negative 5 and positive 1 are solutions. And the last thing I want to point out is if we look at this, positive 5 and negative 1. Positive 5 times negative 1 is negative 5. And if we look at the two middle steps of FOIL, the outer terms times outer terms, and then we add the inner terms. So we do negative 1 times x, which is negative 1x, plus 5x. That equals a positive 4x, which is our middle term. So we're going to look at that when we factor these, and we're going to see how we can use that to our advantage in order to take the original quadratic function and find the factors ourselves without having to have them given to us like here. So that was two solutions. There can also be one solution. So notice the function, and the one solution here touches the x-axis at 2, 0. The factors here are x minus 2 and x minus 2. Again, negative 2 times negative 2 is the positive 4, and then negative 2x and another negative 2x make negative 4x. So those terms, we see that relationship here, and that leads us to see that this function has one solution, which is 2, 0. So it's the value of x that makes the quadratic function equal to 0, is when we talk about a solution. Zero solutions, we're not going to look at that in this app, but that can be further down the road, is when it does not cross the y or the x-axis at all, has no zeros or no roots. It actually has a factored form, but those are complex roots, and we're not going to get into that again. So there's three types: two solutions, one solution, 0. We're going to look mostly at two solutions, and there will be a couple one solutions that come up. So lastly, we're going to look at two cases, and that's what we're going to be focusing on in the app, is we're going to focus on the coefficient a equals 1 and the coefficient a is greater than 1. So when I talk about a, I'm talking about the coefficient of x squared, and then we'll take a look and see what we're going to do. So when we see the coefficient a equals 1, what we want to do is we want to find two factors of negative, or of the c value. So in this case of negative 28, so two factors of c that add to make b. And then here's b. I'll square it so that we know the difference between the two. So there's our b value, and our c value is negative 28. So you can start by listing all the factors. There's only a couple pairs. There's 1 and 28, and there's no way I can get negative 3 out of 1 and 28. But 7 and 4 work. And now, notice that 28 is negative, so it's going to have to be either negative 7 and positive 4, or positive 7 and negative 4. Well, the one that, when we add them together, make negative 3 is going to be this one. Negative 7 and positive 4. So, our solutions, our factors, are this. X minus 7 and x plus 4. So we see that if we were to use FOIL, first, outer, inner, last, we would get x squared plus 4x minus 7x minus 28, and our middle terms combine to make negative 3x minus 28. So that's a way you can check that your factors work, is if you obtain the same function when you factor back out. So this is our factored form, okay? And we know that the value of x equals 7 will make this function 0, and the value negative 4 will make this function 0. So when we write our factors, we write them like this. We find the two factors here that add to make b, that also multiply to make c, and we put the factors as they are, and so we know that the value of x that makes this 0 is 7, the value of x that makes this part 0 is negative 4. So our two actual solutions are x equals negative 4 and x equals 7. So we can see, if we graph this function, we see our two solutions, negative 4 and positive 7. Alright, those are the exact opposite of the two numbers we had to find to make our factors, and we just found out the reason for that is we're actually looking for the value of x that makes the function 0. That's our solution. So our factors are going to end up being the opposite. So there's our two solutions, and then let's go ahead and work on the coefficient a greater than 1. So we're going to, now here, what we want to do is we want to keep track of two things. So we want to do a times c, and that's going to be what we have to work on finding two factors of, a times c. So here's a, here's c. So a times c in this case is negative 30. And then b is negative 13. So again, like if you want to pause and write this down and take the notes, that'd be great. So we're looking for two numbers that multiply to make negative 30, but also add together to make negative 13. So what I see that being is 15 and 2. I can't get that from 10 and 3 because I have to have negative 10 and negative 3 to make negative 13, and I can't do that because my c value is also negative. So I'm going to take 15 as one of them and 2 as the other, and I'm going to have negative 15 and positive 2, because negative 15 plus 2 will be negative 13, and also negative 15 times 2 will be negative 30. So I've got that part down. Okay, so when I write these down, the reason I found negative 15 and positive 2 is because I need to find out the two middle terms when I'm going to write my factors. So if I was thinking ahead and I'm going to FOIL this out, my factors out to check, what would be my middle terms? Well, that's essentially what we're finding here. So in this box, we arrange them in the box. 3x squared comes from the original problem, as does negative 10. And our two middle terms fill in the rest. Okay? So, and they each, since there are middle terms when we FOIL out, they're going to each get an x. So what we now do to look for is to factor in both columns and in both rows. So in this column I have negative 15x and negative 10. So what factors there is a negative 5. Here we have 3x squared and 2x, so the only thing I can factor out is an x. Going this way, I can factor out a 3 and an x, 3x squared and negative 15x. And going my last row, I can factor out a 2. Okay, so I just write my factors like this. I can take the first one and say 3x, and that's a positive 2. And my second one, that's an x and a negative 5. So those are my factors. If I did that again, I get 3x squared plus 2x minus 15x, which is negative 13x, and 2 times negative 5 is negative 10. So it works. And my solutions, the values of x that make these 0, would be x equals negative 2/3 if I was to set each separate factor equal to 0, and x equals positive 5. So those are going to be my two solutions to this, and we'll take a look at the graph. And indeed we see negative 0.667 on the calculator, negative 2/3, and also positive 5 are our two solutions. And as we saw before, we had the factored form down. I believe it was 3x plus 2 and x minus 5. So there you have it. Like I said, you could pause or go back on the video to find those places again, and then you're going to need those and want to have those for reference as you go to the practice exercises and the quiz.